We're picking up where we left off in class. So if you would find your notes and then go to the steps to graphing vertex form. We'll start there. So first of all, we're going to write down what vertex form is. Okay. And then we're going to go ahead and write down the steps. Now, what's nice about this method is you already know how to do it because it's the same method that we used when we were graphing absolute value. The first thing that we did before, which will be the first thing that we do again, is we're going to label the transformations. When you label the transformations, remember that's when we look at the h and the k and we tell whether the graph moves up, down, left, or right. And the next thing that you're going to do is make a small table of values. This is where we draw brackets around the y and the x. And we want to pick easy values to plug in. So the values that we're going to plug in would be quite easy are -1, 0, and 1. That will get us quick 3 points that we can graph and then shift. And that's actually the third step here is to shift your points, draw in a smooth curve, and then again determine your domain and range.
Girls basketball teams. The bus will leave today at 4:15 for the girls basketball game. JV team needs to meet in Mr. Beck's room in the middle school at 3:45. Also, students, tomorrow during advisory, the early college will be here to talk to any interested sophomores about that program. If you're interested, please sign up in the high school office. Thanks.
Okay, and then let's go ahead and do example 2. I'll make sure you get those notes when I'm done with the video. Okay. Alright, for example 2, the one we're going to graph together is going to be 2 times the quantity x minus 3 squared plus 4. Again, I'm going to label the steps so you can match the steps that we do here with the steps that we wrote on the other page. First thing that we do is that we label the transformation. So this 3, just like it did with absolute value, this 3 is going to shift my graph to the right 3. And this 4 is going to shift my graph up 4. And then our second step is to make a small table of values. Now, I know with standard form we had to pick 5 points, but because this lends itself to just an easier way to graph, we're going to only need to pick 3 points. So we're going to pick -1, 0, and 1, and then this is where we draw in the brackets around the x and the y. And when you plug in -1, you always have to perform the function on x when you plug it in. So -1 squared, since that's the function on x, is 1. So 1 times 2 is 2. When you plug in 0, 0 squared is 0. 0 times 2 is 0. When you plug in 1, 1 squared is 1. 1 times 2 is 2. Alright. And then we're going to plot these 3 points. So -1, 2, 0, 0, 1, 2. And then each one of those points has to shift right 3 and up 4. So 1, 2, 3, 1, 2, 3, 4. 3, 1, 2, 3, 4. Right there. Now, the absolute value, the shape was a V shape, but because we're talking about a parabola here, or a quadratic, we know that when we draw our graph, it needs to be a U-shaped curve. So we're going to draw that U-shaped curve in. And then our third step is to label the domain and range, which will be very similar to the domain and range that we labeled before. So the domain for any quadratic like this will be all reals, because you can plug in negatives, zeros, and positives. That should be all reals. And then your range is based on the graph or where the graph stops. So this graph stops at the y value of 4. and it's above that y value 4, so your range is going to be y values greater than or equal to 4. And also notice, just like with absolute value, that that number will match your k value every time. All right, and then with intercept form, go ahead and relabel that. First thing that we do is we find the intercepts. And we plot them on the x-axis. These are the values of P and Q. So whatever those numbers are, P and Q, that's what we're going to graph as our intercepts on the x-axis. Okay. And then we need at least one more point to plot, and that other point, these are two of the most important points in your quadratic. The third most important point is the vertex. That's what we're going to find next. So we find the vertex. We're going to start with the x-coordinate. By plugging in actually I need to rephrase that. A vertex x-coordinate by averaging P and Q. And this is because your vertex is directly in the middle of your intercepts. Because that whole symmetry thing that we talked about, you can't have a whacked out parabola, so it's not going to have a funny shape. It's always going to be directly in between the intercepts. And then you find the y-coordinate of vertex by plugging x in to the equation, plot, graph, and then determine the domain range. The reason this one has so much more writing on it is because we haven't done anything like this before, so I want to make sure to explain more fully. Where like the vertex form, we've done something similar. Okay. And the one we're going to graph together looks like this. In a few minutes here we'll graph. Do you feel better? Good. I'm glad. Okay. All right. For number 1, we're going to find the intercepts. And remember, your intercepts are the values of P and Q. Now, because the general form is x minus P and x minus Q, then it'll be like what makes this 0. Because remember, with intercepts, it's going to be whatever point is on the x-axis. Well, any point on the x-axis is where y is 0. So instead of plugging in 0 for y and trying to do it that way, if you just look at what would make that 0, 1 would make it 0, and negative 4 would make it 0. So actually negative 4 and 1 are my intercepts. But they're also, like, the p value is 1, and technically the q value is negative 4. So those are going to be my two intercepts that I plot. P is 1, q is negative 4, and that translates to the points 1, 0, and negative 4, 0. So those are the first 2 points I'm going to plot, and those are on my x-axis. And then we're going to find the vertex by averaging. Now, when I say averaging, that means just add them up and then divide by the number of numbers that you have. So we're going to add up 1 plus a negative 4, and then because there's just two numbers, you're going to divide by 2 to find the middle part. So 1 plus negative 4 gives me negative 3. So the x-coordinate of my vertex is negative 3 halves. Then to find my y, we're going to take this negative 3 halves and plug it in for x. And I'm going to go ahead and use the calculator to do this. So I'm going to store negative 3 halves as my x. Then I have 3 times x minus 1 times x plus 4. So I end up getting negative 18.75 as my y value. So my vertex, when I put them together, is negative 3 halves, negative 18.75. So because that's such a big y value, I'm going to change my y scale to be by 2's. I'm going to go ahead and plot that. So negative 1 and a half, 4, 5, 6, 7, 8, 9. About right there. And then you're drawing your graph. Okay. And the last thing that you have to determine always is your domain and range. So your domain is going to be all real, just like it's been every other time, and your range is going to be y values greater than that lowest value that we have, which just happens to be that negative 18.75. So your range is going to be y values greater than or equal to negative 18.75. Now just so you know, tomorrow when you come in, we're going to be practicing graphing pretty much the entire time, and then prepping you for the next section. But you'll get lots of practice, especially on this one, because I know this is one that we have not looked at before.